This is reassessment video for angular momentum principle. The question says the mass of a flywheel is 5.6 times 10 to the fourth kilogram. This particular flywheel has its mass concentrated at the rim of the wheel. If the radius of the wheel is 2.6 meters and it is rotating at 350 rotations per minute, what is the magnitude of its angular momentum? So first thing we need to do is know the angular momentum principle, which is at the top here. L equals I, which is inertia, times omega. That symbol looks like a W. It's actually a Greek symbol, omega, and it is the angular velocity. So the L is the angular momentum, I is inertia, and also we can break the inertia down further into its components, which are the mass times the radius squared. And omega, if not necessary in this problem, but in other problems, omega is equal to the velocity, the linear velocity divided by the radius. So we know our mass is 5.6 times 10 to the fourth kilograms, and we know our radius 2.6 meters. And our omega, well, it says that the wheel's rotating at 350 rotations per minute. So first of all, we know that we want to be in seconds. And so we're going to multiply by 1 minute over 60 seconds, and then also multiply by 2 pi radians. That way we're not in rotations per second, we'll be in radians per second. So we'll get a angular velocity of 36.65 radians per second. And we take all of our values and we say that the angular momentum is equal to the mass times the radius squared. So we put our values in, and I used the method of checking your work with the units here. That's always a good thing to do, so we know that we need to be in the right units. And so you're going to get approximately an angular momentum of 1.4 times 10 to the 7th.